All right, welcome. Let's go ahead and get started. I'm going to share my screen. And this is our Intro to Python class. I'm really glad you're here for it. I want to introduce myself. I'm Erik Gross. I am a senior level software developer, a Navy veteran. I mentioned earlier that I was stationed in Washington State when I was in the Navy. I was a nuclear reactor operator, electronics technician, and classroom instructor. Basically, all-around nerd. Was in the Navy for 6 years. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. More about that later. A couple basic class rules. We have an assistant in the chat. Cheska's here. Her job is to monitor the chat, help answer questions, that kind of thing. She'll make sure you're being nice. We rarely have a problem with that kind of stuff. Couple points about the class itself. It will be challenging, not super challenging, but students may run into challenges. Part of the learning process is working through those challenges. So use chat as needed. We do make these very beginner friendly. I try specifically not to talk over people's head or throw around really complex terms. I can't stand it when I'm trying to learn and that happens. One thing I do want to say is that when you see me writing code on the screen, because we're going to be writing some computer programs, right? Be sure to write the code exactly as it's written. And the reason why is that a misspelled word or a missing symbol or even something's capitalized, they shouldn't be capitalized, can result in errors in your code. Try to make sure you're in a distraction-free environment so you can focus on the class and so I don't lose you so you can get the most out of it. Here's a big one. If you fall behind, listen and learn. Don't worry about getting lost or if you can't keep up. Just stop trying to type everything and just watch and listen. You absolutely will still get a lot out of the class when you do that. A lot of times people ask if we record these. We do, and the recordings will be up on YouTube within the day or tomorrow at the latest. You'll also get a full copy of all the code of the game that we're going to be talking about at the end of the class. So you'll be able to play the game and mess around with it and have fun, okay? And finally, we'll provide you with links at the end to future events, free videos, other resources. Again, use the chat. Let me look at participants. We've had a few new people arrive. So let me, where is the participants thing going? All right, there it is. Do me a favor, drop in chat, if you haven't already, where you're joining us from. I'd love to see that. All right, Orlando, Florida. That's where I went to boot camp. There used to be a Navy base there. Toronto, excellent. All right, got people from all over the place. I love it. Okay, good. So here's the basic agenda. We'll give you a short explanation of the Tech Academy, who and what we are, and then we'll write code. And during the code, there'll be a little bit of back and forth. I try to monitor the chat, but when we're done writing the code, there'll be a brief Q&A session to catch any questions that we weren't able to pick up while we were writing code. We'll go over some information about our boot camps, and there's a free gift waiting for you at the end. I think you'll like it. It's one of the more popular things we've created over the last 10 years. And full class take about an hour, hour and a half. All right, so quick introduction to the Tech Academy. First of all, I just want to cover what boot camps are. If you're not familiar, a boot camp is a technology certification program, really intensive program designed to prepare people for entry-level positions in tech. Typically, they'll be 6 months, depending upon where you go. They focus on modern practical skills. We at the Tech Academy have been offering really thorough, budget-friendly, flexible, trusted coding boot camps for over a decade now. We were around at the very beginning of this industry because the coding bootcamp industry has only been around for about 13 years, right? Our certification programs are really cost-effective. They're self-paced, fully online. They're tailored for beginners, people with no prior technical coding knowledge. And they cover in-demand skills. They're endorsed by stellar online reviews, and they're flexible enough to be able to fit around your personal schedule. And we try to prepare you for your technology career with a really well-rounded toolkit. Nationally, at least in America, the average cost of boot camps is around $13,500. Ours are well under the national average. In fact, we have boot camps that start with $59.80. And we always like to go over our mission statement. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards. and surpass client expectations. That's our mission. Our product is you working in tech. All right, so let's get into this. Let's cover a few basic definitions before we jump into writing code. And first of all is program. What is a program? Well, it's a set of written instructions that you can enter into the computer. You can be in charge of the computer instead of the computer dictating what you have to do. So you can enter these instructions in the computer and make it perform specific tasks. That's a program. A programming language is an organized system of words or symbols or phrases, and they are what let you communicate with the computer and tell it what to do. It's used in this programming language that you can direct the computer to do specific actions. You use them to write these programs. There's thousands of different programming languages. Then there's coding. It's a verb. It's the action of entering these instructions in. When you're typing in these instructions, that's called coding. The actual instructions you write in, those are called code. And finally, Python. It'd be pretty important to talk about this because that's the language we're going to use today. Python's a really, really popular programming language. It's about 35 years old. And what's a couple really cool things about it is when you read it, it reads very much like English. It's easy usually to kind of read through it and kind of get the logic of what it's doing, which makes it very beginner friendly, but it's also really flexible. Like you can create all kinds of different programs, applications, websites, games, all kinds of things with Python. So it's very, very, very popular in the world. All right. So I want to show you the framework we're going to use to teach you this basic coding. And what we're going to cover on this slide is actually more important than the coding we're going to do today. In fact, what's on this slide is, in my opinion, if you're trying to break into technology, if you're trying to learn to program, what we're going to cover on this slide is actually some of the most important information you'll ever learn in programming. And what it is the 5 basic elements of any computer program. Every program has these. And there's no other things in a program. It's only these 5 things. So they're pretty important to learn about. Now, we're going to cover the basics. On our boot camps, you dive way deep into these. But here's the basics. Entrance point. Every computer program needs a first instruction. The big reason for that actually doesn't have to do with the program itself. The big reason for this is because when you start a program, when you run a program on your computer has to do a bunch of housekeeping things that help your program run. One of the biggest is this. Inside your program is a bunch of areas, physical devices, to store data in. They call them memory storage devices. You've probably heard the term RAM before. It stands for random access memory. It's a physical device about 3-4 inches long. And on that device are literally billions of tiny little locations. Each one you can store some data in. So they're really cool little devices. So here's the big deal. When you start running a program, the computer needs to allocate some of that data storage area only for your program and let no other program touch it, so no other program that's running on your computer can overwrite the data that your program needs. That's one of the biggest sort of housekeeping things that happens, and it happens the moment the first instruction of your program is executed. So it's kind of important to know about the first point, the first entrance point of the program. But there's another real important reason for you, not the computer. When you come onto a team and you inherit this big, huge computer program that the team is responsible for, one of the first things you're going to want to do is start looking through the program and figure out, how does this thing work? And one of the most valuable tools you have is the knowledge that somewhere in that program is the first instruction. And knowing how to find that for each different type of program or different programming language is really, really important. Because when you know the very first instruction, you can go to that in the program and start reading through one instruction at a time and start to grasp what this program does from the moment it starts running, which is really helpful to us as programmers. So that's the first fundamental element of any program, is an entrance point. Second fundamental element is called a variable. A variable is a part of a program that keeps track of data that can change while the program is running. If you're playing a game, your score changes while you're playing the game. That score is stored in the variable. third really important element of a computer program is control and branching instructions. You need the ability to tell your program to make a decision. You've got one of two or more possible courses of action that could happen. Those courses of action, we call them branches, like branching off of a tree, right? So you need a way to control which of those two or more branches does your program take. This one will become a lot more clear when we write our actual code, but I think you can see that a program wouldn't be very useful if it couldn't make decisions. That's a lot of what we use computer programs for. Next, really key element of any program is what's called a subprogram. And you can really think of it as a program within your program. These are really cool. This is a set of instructions that might be needed many different times while your program is running. Same exact set of instructions gets used over and over and over again while your program is running. Years ago, programmers recognized it to be kind of a smart idea to take that set of instructions, put them in a little box, if you will, and call it a subprogram. And that way, whenever you need that exact series of instructions to happen, you just call on that box, that subprogram, and say, hey, go do those things. Go do those instructions over there. When you're done, come back where you were when you left off. And that's what a subprogram is. And again, you're going to build them tonight. And then finally is an exit point. Every program needs to have a final instruction. And that's a way to tell the computer that the program is running on, hey, I'm done. This program is signing off. And the computer needs to know that so it can take care of all the housekeeping things it set up for the program in the first place, including if it was reserving a bunch of that data storage in the memory device, it can now mark it all and say, hey, this is no longer reserved. Other programs can now use this space. So there you have the 5 fundamental elements of any computer program. They're not always in this exact order, but if you look through any computer program, these are the only things that are in it. An entrance point and an exit point, and then in between those, a bunch of variables and control and branching statements and subprograms. And that's all there is in a program. Yeah, they can get pretty complex, but this can simplify the concept for you. So we're going to write some code that shows how to do all those 5 things. And we're going to do that in a code editor. Code editor is a 2-part tool. One is a text place where you can enter in a bunch of text. That's your instructions, right? And the other is a place to see output. So if you look in chat right now, Cheska has dropped a link, and I want you to click on that link, and that's going to open up the code editor that we'll use for this class. I'm going to open it up myself in a moment, but for right now, I want everybody to click on that link in chat and open up your own code editor. Now you're going to see something like this over on the right here. You're going to see a window, probably with some code in it. Ignore that code for now. And on the right is another window. So that's what you will see. Now listen close. Here's what I need you to do to make this class go well. First of all, for any of you that have 2 monitors, you're in luck. Put your code editor on one monitor and put me in the Zoom call on another monitor. But if you've only got one monitor, I want you to put me side by side. I'd like the code editor on the right and then the Zoom call on the left. If you have a little bit of trouble with that, because sometimes these windows are a pain, for Zoom, if you click on the word Zoom meeting, this little restore button is there. If you click on that, it'll make it easier to control the size and position of your Zoom window. And for the browser, if you look at the top right of most browsers, is this little symbol. It's like 2 squares on top of each other. If you click that, it'll help you resize your browser. But go ahead and take the time to set these 2 things side by side. Code editor on the right and me, the Zoom call, on the left. I'm going to take a sip of water while you get that set up. All right. And now let's dive into coding. Now, the first thing I'm going to do is show you what we're going to build and show you how it works. We're going to be building what's called a magic 8-ball. Now, if you didn't experience one of these growing up, it's a round black ball with a little window in it, and it's filled with liquid. And inside that liquid is a little like dice, a little die, and a singular of dice is called die. And it can float around in there, and you shake it and you ask a question like, will Jenny ask me out to the school dance? I had a lot of trauma in middle school. Leave me alone. You shake it and ask, well, Jenny asked me out to the school dance, and then you look at the little thing and it pops up, sources point to no, and then you go cry in the playground. Okay, that's my story. So this is what game we're going to play. So the first thing I'm going to do is I'm going to show you that full game. So first, let's go ahead and delete, collapse that for a second. Go over here, and this is all of the code for the game. You're not giving you this yet. You'll get all of this towards the end, but I'm going to copy this code. I'm going to go over here. I'm going to paste it in, and I'm going to click run here, and I'm going to run the game. So you'll see over on the right, it says, ask the magic 8-ball a question. Well, just because I'm a glutton for reliving painful memories, will Jenny ask me to the dance? Oh man, I'm afraid. Ask again later, but the dance is tonight. All right, I'll try it again. Okay, but will she? Oh, yes. Awesome. Okay, good. All right, I'm done playing. I'm going to type exit and quit. That's the game. Okay. Not the most sophisticated, awesome game in the world, but also not the worst game. It's kind of fun. And over here on the left, don't try to read all this. This is all the code that's used to make this game. Now, by the end of the class, you'll be able to read through this and understand a lot more of it than you might right now. But first, I'm going to erase all that. And again, you'll get all that code at the end. Okay. Oh, no. Jessica, you gave him the code. That's fine. Don't worry about it. Okay, good. Don't use that code yet. Okay. It's not bad that you have it. So let's look at this, this code editor on the left here. The first thing I want to do is just start writing a couple very simple instructions in Python, because they're just really good teaching moments for some of the basics of this language. The first thing we're going to do is we want something to print over on the right. The Magic 8-Ball program printed a bunch of stuff on the right. Can we get something to print on the right? Not surprisingly, the instruction in Python to print something is print. So over here, I want you to type print. Now, I'm going to enlargeify this so you can read it a little bit better. Let me know in chat if you can read that decently well. How is that? Yes or no? Can you read that well? Excellent. I got a yes, a couple yeses. Thank you. Now, we're going to finish the whole instruction, then I'm going to explain it. Print, open and close parentheses, double quotes, hello world. Oh, maybe you should spell world correctly, Eric. Oh, I don't know. All right, now, go ahead and run it. That's the play button kind of up here. And it works. If it doesn't work, make sure you've typed exactly what I have. I'm going to give it a second. And we're actually going to talk about this because there's a fair bit to learn about programming and about Python just from this one line of code. All right, so let's talk about a couple of things, and we're going to go kind of slow on this portion because this is actually pretty vital data when learning to write in any programming language, and of course in Python. First thing to think with is that any programming language has a bunch of words that belong to that language. And print is one of them. This is an instruction for the Python language. You're not allowed to use that word print for your own use in a program because it's what's called reserved. It's a reserved keyword. It just belongs to the language Python. Now, let's talk about another aspect of this. We have this instruction called print, and notice that immediately after it, no spaces, immediately after it, we have some information that is inside of parentheses. And this brings us to one of our first really, I think, interesting or important points. Many instructions in Python need to be given some information before they can actually do their job. And this is a really common thing in programming. In order to perform a specific type of work, information needs to be provided to the to the instruction. Okay. All right. So that's what parentheses are all about. Inside the parentheses is the information that the instruction needs. What kind of information does the print instruction need? It needs text information, because that's what we can display on the screen is text information. So we give it text. How does Python know that it's text? Well, it's inside of double quotes. And that means everything inside of there is text to be displayed on the screen. You could go and change it. Let's go and capitalize the W and then print it again. And we've changed the information given to the print command. Now, to some, this may seem simple, but there's a couple really, really important things that if we cover them, can help eliminate some roadblocks for you when you're trying to learn to code. I want you to take me on a little bit of a, I'm going to take you on a little bit of a tour. We're going to pretend that you are the Python language. Now, actually, let me be real precise. On the computer at this website, we have this website we go to, trinket.io. On the computer is a program called Python. And Python is what reads the characters you just typed in. And I want to show you how that program, Python, actually does that. The program, Python, will start at the very beginning of this sentence. And remember, Python can't think. Python has no intelligence. Computers can't think. Computers have no intelligence. They can only do one thing at a time. I'm going to show you what Python does. First, it reads the first character. And then it looks up in its own internal list of all of its reserved instructions and says, does this match any of my instructions? Well, it turns out no. There's no instruction. It's just the letter P. It's, oh. Is this a variable in the program? Well, no. We don't have any variables in this program at all yet. Oh, okay. All right. Well, then I can't do anything with it. Let me go on to the next one. And then it reads two characters and does the same thing. Is this an instruction in Python? Because it's got a list of them. No, it's not. Okay, is it a variable? No. No variables. All right. And so on and so forth. And all of a sudden, after it's read 5 characters, it looks in the list of instructions and says, is this an instruction? This is an instruction. Oh, it's the print instruction. And now Python, the program, knows exactly what to do. It says, okay, the next thing I'm going to see is a parentheses. Let me look. Oh, it is. And now Python says, okay, I've got to look for a specific pattern here. I need to look and find the closing parentheses. And so it'll go past all of these characters. It's ignoring them. It doesn't care about them. It goes all the way to here and says, I found the closing parentheses. Okay. It says everything in between these two is what I need to print to the screen. So then it goes back to the beginning and says, all right, I need to find the data to print to the screen. It's in between these parentheses. What's the first thing I found? Oh, I found a double quote. Good. I have a pattern built in that says if I can find the matching double quote, then everything in between is what to print on the screen. Hey, I found the matching double quote. So now it literally goes back again and reads only that content, and only that gets printed to the screen. Now, I know that sounds extremely like step-by-step nerdy. That's literally how the language works. And the reason I went into that nerdy detail is to reinforce for you, one, that the computer can only do one thing at a time, and two, that the Python program that's able to run all of your code is literally going to go through your code one character at a time and try to match up patterns that have been built into the language. And so when you are reading code and it's not quite doing what you think it's supposed to do, you sometimes have to stop, step back, and pretend you're the computer. Pretend you're the Python program reading through it And sometimes you just go one character at a time and go, is this built? Did I write this with the right patterns that Python's expecting? It can sometimes be that laborious or minute a look. But if you don't know that that's actually the same thing that the Python program is doing, you might not think to do that. All right, let's step back out for a second. We have our first instruction. It is called print, and we can print text content. Fine. Now let's start using some variables. So let's kind of relate it to the game here, okay? We have a game where people are going to ask questions. So we might want to have a variable that holds their current question. That could change every single time they play, and they could play for a long time. So let's make a variable that's just called question. And that's how variables work, is you give them a name. So type question, question, and then a space, and then equals, and then give me 2 double quotes, and then why is the sky blue? It's a question. Actually, you're supposed to answer yes or no questions. Let's go back and say, is the sky blue? There we go. Good. Now, before we run it and everything, let's just talk about this. There's, again, super important, vital, fundamental data about programming right in this one instruction. We talk about variables. I'm going to explain to you technically what happens inside the computer, but I'm going to start with an analogy. You can think of a variable as a bucket, and on the outside of it, it has a label. And it has to be a unique label. No other bucket can have that label. That is called the variable name, or the identifier. Bunch of nerdy terms. But it's a bucket. It's got a unique name on the outside. Inside the bucket is the actual information that you're trying to keep track of. Say, the player's score, or what's the current question that the player is asking, or what were the total sales for last year, or whatever, right? You're trying to keep track of some data. That's what's inside the bucket. So that's just an analogy. Let's talk about what actually, for real, physically, happens inside the computer. In the computer are those memory storage devices. I talked about them earlier, and I said that on any one of them, there might be billions of little locations. Each one of them you can store some information in. Each one of those locations is where you can store a variable. And the location is going to have 2 things: the name of the location, and then the actual data stored in the location, just like our bucket. So let's talk about that in context of what we just wrote in our code. We made a variable called question. Think of that as the name written on the outside of the bucket. Or down inside the computer, that's the exact identifier for a specific location on the memory storage device. No other identifier, no other location can have that exact same name. It's got to be unique. Okay, good. So that's our program name. And what we're doing is we're declaring, that's our variable name. We are declaring the variable. That's the technical term. It's called declaring the variable. I declare that there is a variable, and it is called question. You don't have to say it like that, okay? Now, what's this symbol right here? This equals. That is an instruction for the Python language. It's actually a special instruction called an operator. An operator makes the computer do something. That's what an operator does. The operator makes the computer do something. In this case, the operator makes the computer put data inside the bucket. It makes the computer put a value in that actual location in the memory device. In this case, the value is a string of alphanumeric characters that says, is the sky blue? So let's talk about, again, the terminology. The terminology is we are declaring a variable. We're declaring a variable called question, and we are assigning a value. 3 things: the variable, the assignment operator, and the actual value. So that's all we're doing. But it's important to know that there's two things happening on this line. The first is declaring the variable, and the second is assigning it a value. Okay, good. So we have this variable. What are we going to do with it? Well, why don't we print it to the screen? We know print. Let's do print. Now, this is different. We're not going to put in here something inside double quotes like we did before. Instead, remember how I said that many instructions need to be given some information in order to do their job? Here, the information we gave to the print instruction is some actual text. Here, we're going to give it our variable, question. Now, what we're really doing, and this is critical, it can lead to some confusion when you're starting to learn to program. What we're actually giving to the print instruction is the value that's been assigned to the variable question. That's what we're giving to the instruction called print. So go ahead and run this. And notice it actually printed out the text, the value that was stored in the variable, which is kind of cool. Remember, variables are for information that can change. So let's add in something else. Let's say they changed the question. Let's say the question now becomes, are the 49ers the best team ever? And the answer absolutely has to be yes. Sorry, just the way it is. So now, don't run the code yet. Do not run the code. Don't run the code. I'd like you to take a guess in chat. Tell me exactly what you think is going to print out when we run this. Tell me what's going to print on the screen. Take a guess. I'm not going to say anybody's names. I'm just curious what you think. Will, I think Will, I get where you're going, but type the exact thing that it's going to print. Okay, good. Awesome. All right, I've gotten some, is the sky blue? I've got some, are the 49ers the best ever? Got some more of those. Okay, good. So it's not going to print my 49ers thing. Let's run it. And it doesn't. Now, if you were confused about that, don't worry. Lots and lots and lots of people are. It's totally normal. So this is why it works this way. A computer does one thing at a time, and it does them in the order you tell them to. This program we wrote, we're telling the computer, start at the top and do each instruction one after the next. So the first instruction that the computer finds is this one. So it does it. It prints hello world. The second instruction it finds is create a variable called question and assign it the value is the sky blue. So it does that. The next thing it finds is an instruction to print, this is important, the current value of the variable called question. So it does that. Only when it's done with that do we then change the value of the variable question. It's a matter of time. It's literally one after the other. So when we run this instruction, the value of question has not changed yet. And that's why it still says, is the sky blue? What do you have to do to get it to print the new one? Now you have to do another print question. So put that in. You're absolutely right, Atik. It works like it's an interpreter line by line. You're absolutely right. We run this, and now it'll do the first one, and then the second one. And again, I know this might seem like a relatively fundamental or kind of simplistic way of demonstrating this, but it's so important to know the true value of a variable. The value of a variable is to keep track of stuff that's going to change while our program runs. There are sometimes thousands of pieces of data that can change while a computer program is running. Each one has to have a variable. Each one needs to be safe. It needs to have an exact spot on those memory devices that no other program is allowed to mess with, so you never lose your data. The data is the most important thing about this whole process. By the way, do you know what the purpose of a computer is? It's to take in data, process the data in some way, and then send data on. That's actually the complete and total purpose of a computer. To take in data, process the data in some way, and then send the data somewhere else. So the data is pretty darn important, and we don't want anybody to mess with the data that the program's trying to work with. All right, so we have our first instruction right here. We've made use of some variables. Now let's talk about control and branching. In other words, we've got two possible courses of action, and we need to control which one the computer takes. So let's just pretend for a moment. Here's a good one. Let's say it's you and your sibling, and you're both fighting over who gets to use the magic 8-ball, and each of you only get 3 turns, and after that, you have to give it to your sibling. Not that I'm revisiting my childhood years during this class, but what we need to do is, if we're writing a program, we've got to keep track of how many turns has a person had. So let's make a variable called turns. And let's start it out at 0. And now we need to write some code that can tell whether or not they need to give the magic 8-ball back. This is only one or the other. Either you've not used up all your 3 turns, or you have. It's a yes or no, true or false. That's it. There's no ambiguity. Now, it might not always be that way with siblings, but it's that way with computers. So let's write some code that will make the decision for us. It starts with a control instruction called if. Now, if is a Python instruction, and it's it has something to do with like print, in that it needs some information to do its job. The information it needs to do its job is a lot different than the print instruction, though. What the if instruction needs to do its job is some code that the computer can understand that's either true or false. No ambiguity. It's either yes or no. That's it. They call that thing an expression. Okay? It's an expression. So we need to create an expression that's only true or false, never in between, never vague. What do we really want to know is the number of turns greater than 3? If it is, I'm sorry, man, you got to give the magic 8-ball to your sister. So here's how you do this in Python. Any of these control instructions, like if, you put a parentheses immediately after it, and inside the parentheses, you put something, usually a comparison, that the computer can look at and go, yes or no. Simple, straightforward, yes or no. In this case, we're going to compare whether the value of turns is greater than 3. This symbol is an actual instruction to Python. It's another of those operators. But this operator is an assignment operator. It tells the computer, assign a value to a variable. This operator is a comparison operator. It tells the computer, compare the 2 things on either side of me, please. Specifically, it says, compare the 2 things on either side of me and tell me whether the one on the left is bigger than the one on the right. That's exactly what it's saying to do. And it's very similar to the mathematical symbol we've probably all seen before in middle school or high school, right? But the important part is that inside of these parentheses is some code that is only ever true or false. No in between. And so now we can exert control over our computer program. We can provide it with two different things it can do, two different branches. The first branch is going to be, what do we do if this is actually true? So go to the end of this instruction and put a colon. And now we're about to write what to do if you've exceeded your 3 turns. Hit enter and notice that the cursor is indented by 2 spaces. You see that? We're indented by 2 spaces. This is another super important thing about Python. In most cases, when you're learning Python, a lot of the errors you run into in trying to write code revolve around this next thing. So please listen pretty closely to this. In Python, you can control whether or not an instruction gets performed by how it is indented. Indentation is super important. So let's look specifically what we're doing here. We are saying that if a specific condition is true, and only then will you perform some certain work. The work to be performed has to be indented. So what do we want to do if the turns is greater than 3? We want to print, you have to give the 8 ball back. But what if it isn't? I'll give everybody a second to get caught up. What if it isn't? What if it's not greater than 3? Well, hit enter, but do not start typing here. The next instruction we're going to type, don't type it yet. The next instruction is called an else. It's what to do if it's false. What to do if turns is not greater than 3. But don't start typing it. And here's the reason why. If you start typing anything right here, blah, 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 anything you type that's indented by these 2 spaces is only going to happen if turns is greater than 3. And that's why the indentations are so important. Let me erase this. We're done with the instructions on what to do if turns is greater than 3. So we need to return, by hitting delete once, we need to return over to the left so we're not indented. It's a critical thing about Python. It's just a decision that Guido van Rossum, the creator of the language, made about how to indicate when a certain chunk of code should be performed and when it shouldn't be. And he decided that the indentations were the way to do it. But if you don't quite grasp that, it's real easy to make indentation errors in your code. And then you're like, what is going on? Okay, good. So we have the first of the 2 branches. We have what to do if, in fact, turns is greater than 3. Now we need to put down what to do if turns is not greater than 3. And you do that with an else and then a colon. We're about to build the branch, the section of code to do if it's not greater than 3. Well, hit enter. Notice it automatically indented because it knows you're about to put in some instructions that are not always going to happen. It's a separate chunk of code. They call it a block of code. Well, what we want to do is print, you can keep playing. That's it. Now, again, the logic inside our game, a real game, might be a bit more complex. I'm just illustrating the ability you have in a computer to control whether the computer takes one of 2 or more possible courses of action, which is a super important part of any program that's going to be of use to human beings. So let's run this. And you'll notice it says you can keep playing. Why? Because at the time we made this comparison, the value of turns was 0. Well, let's go ahead and change it. Change it to 4. You're trying to take a 4th turn. Sorry. Run it. You have to give the 8-ball back. Sorry. So now we have, in fact, built a section of code right here where sometimes part of the code runs and sometimes it doesn't. You have built the ability for your computer program to make a decision, which is, again, super critical. Now, when you get into programming in real applications, you might find more complex systems that determine which path to take, but they all come down to the same thing. You have to be able to communicate completely true or false decisions to make. There can never be a vagueness. It can never be like, is turns greater than 3? I mean, sort of. There's no sort of in a computer. Computers don't do sort of. They do yes or no, true or false, on or off. That's it. And so that's how you have to write the logic inside of your programs. All right, good. So let's get to one final cool thing here of the 5. Hit enter a couple times. Make sure you hit backspace so you're back at the original level. And now let's talk about a concept. How many times do you think we're going to need to check whether or not the number of turns is greater than 3? Let's just picture the real world. You and your sister are playing back and forth with the magic 8-ball for like 20 minutes. And over again, you may not be a computer, but you are absolutely keeping track of whether or not your sister has had her 3 turns. And the moment she's done with her 3rd turn, if she tries to take a 4th turn, you are like either grabbing the magic 8-ball or going, Mom, you're stopping. You're trying to enforce a different path of execution. That doesn't mean you're going to kill your sister. It just means you're trying to do something different. So we need to build a way in our program that we can make this check of whether or not the maximum turns has been used up over and over again without having to write these 4 lines of code over and over again in our program. Well, it seems like time for a subprogram. So let's make a subprogram. Let's make this series of instructions, these 4 instructions that I have highlighted. Why don't we put them in a nice little self-contained box and give that box a name? And then every time we need those 4 instructions that you see highlighted, every time we need those to be performed, we can just ask for the box. And that's essentially what subprograms are. So here's what we're going to do. Go right above the if. Look where I put my cursor. Hit enter. Enter a couple times just to give yourself some space. All the blank spaces don't do anything in Python. They just make it more readable for you as a human. We're going to create a function. A function is what we call subprograms in Python. Repeatable sections of code. So the way you do that is you have an instruction in Python called def. It stands for define. After that, you put the name you're going to put for this collection of instructions, the name of the subprogram. We're going to call it check 3. I like that. Check 3. That was a good one. Now, let's stop. Do not hit space. Let's talk about something. Remember when we first talked about this built-in instruction called print? And we said that there are a lot of instructions inside of Python that need to be given information before they can do their job. And we said that you put that information inside of parentheses. When you build subprograms, you've got to think the same way. You've got to think about whether or not the subprogram you're making needs to be given some information before it runs. And whether or not it does, you have to put open and close parentheses right after the name. Inside those parentheses, if the subprogram you're making does need to be given some information, that's where you put down the information it's going to receive. So let's talk about the information it's going to receive. It's going to receive like the current number of turns that someone has, right? Like if they've completed 3 turns and they're about to start the 4th, you would give it a 4. So we're going to put in here a variable, and we call it current underscore turn. Like, what's the turn that we're about to start? We're about to start the 1st turn. Okay, you're golden. That's fine. But if you're about to start the 4th turn, now we got a problem. And again, you and your sister are coming to blows. So we're almost done with this line. We have the instruction define, which tells Python, I'm about to create a subprogram. Again, in Python, we call subprograms functions. It says, we're about to create a function. We have check3, which is the name we get to choose. We can call it whatever we want. It's the name we've chosen for our function. And in the parentheses, we have what information we're going to give to the function when we actually use the function. The information that's going to be given to the function is going to be called current turn. Okay, good. Awesome. All right. The last thing you need is a colon. And here's why. You're about to create an indented set of instructions that are only going to be performed when you request this subprogram to run. And so when you're about to have a set of indented instructions, you have to have a colon on the line before it. So what we're going to do, watch this, we're going to indent each one of these lines by tab, go down to this one, tab, go down to this one, tab, only hit tab once. And look, we've indented all those instructions. It's kind of cheating, but I didn't want you to have to type them all over again, and I certainly wouldn't if I was programming. I already know that this code works. Now, I'm going to give a second for everybody to get to where I am. Make sure that your indentations look exactly like mine. And then we're going to talk about an extremely important concept in programming, one that will get you wrapped around a tree if you just don't know what's going on with it. So I want to take you on a little trip here. Look at this function we're making called check3 and visualize it literally as a box. And inside the box are some instructions that are going to do some work. When you open the box and put some information into it, that's what this current turn is. That means that inside that box, the information you gave it is called current turn. And nothing outside of that box should be used while the work is being done. So I want everyone to think about this. What is wrong with this code right now? Atik, I think it's backwards from what you said. Current turn should be turns. It's actually the other way around. Let's look at this. Can almost think of these parentheses as, yes, exactly right, Atik. The parentheses is lifting up the lid and putting something into the box where the work's going to be done. Whatever we put in there, from that moment forward, this name is what is used inside the box. So we can't use turns. It's outside the box. We have to use current turn. All right, so let's use this bad boy. Let's use this function. Now, don't run the code. Don't run the code. Don't run the code. I would like you to put into chat your guesses as to what's going to print on the screen when we run the code. Someone put a guess. What's going to run on the screen when we run the code? Good job, Atik. Thank you for showing up. I know you got to drop. Someone take a guess here. What do you think is going to print out on the screen when we run this code? Woo! Atik, you got it spot on. Okay, so 4 people answered, got 2 right, 2 wrong. Here's the right answer. It's going to print, hello world, is the sky blue? Are the 49ers the best team ever? It is not going to print, you have to give the 8 ball back. Let's run it. And look at that. It doesn't print it. And the reason for it, Heather nailed this. She said, we never used check 3. And this is such a critical point that it's going to take I'd like everybody to just pause for a moment. We made a function here called check 3. And here's the important thing. A function is only a description of potential behavior. It is work that might happen, but only if you ask it to occur. The creation of the work that could happen does not make it happen. You have to ask. We have to ask for the function to be done. We never asked for it to be done. All we did was say, if you were to run this function called check 3, here's what I would do. And I know I'm being nerdy and sarcastic and everything, but it's such a critical thing. I made this mistake a lot early on. When you make a function or any subprogram, it won't run until you ask it to be run. And it goes back to that fundamental concept. The reason we make these subprograms in the first place is there's a series of instructions that otherwise we'd have to repeat over and over and over again in our main program. And so people decided, no, that's really a waste. Why don't we put them in a special box? And when we need that set of instructions to happen, only then do we request the work to be done and then come back where we left off. So how do we request the work to be done in Python? Well, go to the very bottom here. Make sure you're fully indented all the way to the left. To call one of these subprograms, that's the terminology. You call it. To call one of these functions, you just type its name, check 3, and in parentheses, if it needs information, give it the information it needs. Let's say someone's about to start their second turn. They're about to start number 2. Now run it, and it says you can keep playing. Why? Because we got to my line 16 right here, and 16 says, hey, you know this potential behavior that was defined a little while ago? Can you please do that now? Oh, and I know you need some information in order to do that work. I'm going to give you the number 2. And so only then does Python go, oh, you want me to run this function called check 3? Oh, yeah, I've got that stored somewhere. Okay, I'm going to run this, and I have the value 3. So current turn is equal, 2. I was given the value 2, so current turn is equal to 2. So is current turn greater than 3? No, current turn is 2. So, I get to print, you can keep playing. That's how it works. But watch. Let's say they took another turn. Let's do check 3. And they're about to start their third turn. Okay, well, let's run it. Yeah, you can keep playing. But now, nope. Check 3. And they're about to start their 4th turn. And this is when you and your sister, man, you have to give the 8-ball back. So again, I want to show you, look at how cool it is to only write 3 lines of code instead of 12. Also, get this. What if you wanted to change one of these paths? What if you thought the 3 exclamation points was just really too antagonistic and we just want to change it? We only have to change it in one place. And now, every time you run it, it uses the new change. If you didn't do that, you have to go back to every single place that you had these 4 instructions and change it in every single location. And those are some of the reasons that subprograms are awesome. And again, in Python, we call subprograms functions. So, I'm sorry. I just think that stuff's really cool. You've now built a set of instructions that you can call on anytime you need to in your program. And you can go back and change them as needed, and that change is reflected every time the function is used. Okay, so let's look at the actual code. So many of you got this link. Cheska, can you drop the link into chat again? I'd like you all to Control A and then Control C, select all, and then copy. If you're on a Mac, it's Command A, Command C. Copy all this code, go back to the code we wrote, select all of it, and then paste. And now you have the full program. Oh, sure, I've got it, Cheska. Hold on. I should never have asked you that, Cheska. I knew that it was the wrong link in the spreadsheet. I'm so sorry. Okay, so that link that I just dropped in, I didn't do it to everybody. Everyone. There it is. Grab that link. Atik, I'm sorry. I'm not trying to mess with you. So now you have the code. Again, delete everything you had and paste all that code in, and then hit play. And you can play Magic 8 Ball. Is Erik a super nerd? You know, my business partner built this program. He probably programmed it to say that. Fine. Is Jack a nerd too? Oh, man. Now I know he programmed it. All right. I want you all to take a minute and play around with it as well. And then we'll look at the code and you'll be able to understand a bit more about what it's doing. All right, so let's look at this code. The first thing I want to explain in the code is this green colored stuff. Notice it has a hash mark at the beginning. Those are how you do comments in Python. Comments are not executed by the computer. The computer reads them and ignores them. They're only there for human beings. They're there for you and anybody else who looks through your code to kind of understand what's going on. But let's go to the top here. I want to explain a Python instruction that we didn't cover. It's called import. To understand import, you have to understand the concept of what's called a module. In Python, a module is a collection of pre-made Python code. More precisely, it's a collection of pre-made Python functions that you can use. You see, there's lots of common types of work in programming. Things like generating random numbers that we need for our games, or things like doing really nerdy complex scientific calculations, or things like interacting with the file system on your computer. that, quite frankly, once one person solves it really well, there's no need for every programmer who needs to do that thing to write their own version of how to do it. And so a lot of helpful, intelligent programmers over the years have just made these functions and given them to the world. That's what random is. Random is a collection of functions. Again, it's called a module that helps generate random numbers, which, by the way, is actually really hard on a computer. I don't know if you'd think that, but it's really hard to generate random numbers. And so what we're doing is, on the computer where this website is, someone installed this collection of pre-made functions called random. We want to use that in our program, so we import it. That's all import does. It says, hey, please make this collection of code available. All right, now let's move on. Notice the first thing we do is we define a function. So the work inside this function, remember, isn't going to happen until we call this function called Magic 8-Ball. And then you can kind of see what it is. List of possible responses. Oh, okay, there's a bunch of responses. It's just a big collection of responses. Okay. And then it's got some while this is true, ask a question. And then if it's exit, then print goodbye. And then if they don't put something in, say, please ask a question. And, oh, otherwise, print a random choice from the responses. That's the game, really, right there, isn't it? It's like, hey, until someone types exit, keep on asking them the question. This is the core of the game. And notice what it makes use of. It makes use of variables. There's a variable called question. It makes use of built-in instructions like input. You can tell that that prompts the user for something. It makes use of control and branching statements. If the question equals exit, then do this. Else, if there's no question, then say, please ask. So you can almost read this. You can almost read this. Even after like an hour, you can go, oh, I kind of can tell what's going on here. We've got control instructions. We've got variables. Okay, yeah. And we've got some subprograms, they're all in there. So again, it's a relatively simple program. When you're through one of our boot camps, you can make extremely complex web applications and full-blown programs and all kinds of other stuff. But I just want to give you a little bit of a taste of what this looks like. Now, let's get into some Q&A. So please post any questions you have in the chat. Time for a couple of questions, if anybody has anything before we move on. Yeah, Atik, you're right. Random is basically just choosing a random string from that big list. So it's not magic. All right, so let's move on. Give me just a second. There's something on my glasses driving me up a wall. Okay, good. So let's talk about the Tech Academy and the boot camps that we offer. If anything intrigued you tonight, if there's any aspect of writing this code and working through the logic and trying to think a little bit like a computer and all this kind of stuff that made you go, hey, I kind of like that, then you might like this. We have, and by the way, please stick around for your free gift. We'll be there shortly. We're almost done. So we have 12 online boot camps that, as you can see, cover a wide range of technology subjects like artificial intelligence, which is kind of popular right now, computer programming, website development. Atik, you're not allowed to comment anymore. Atik said, it's better magic than your childhood traumas. All right, you're killing me. William, I will get to that question in a moment. That was a good question, and you deserve to have the answer. Okay, I'll get to it in a second. So these boot camps, like you can see, they cover, in fact, we have more certification programs than any other coding boot camp on earth in these 12 boot camps. But more important is how they're run. They're self-paced, but they're also instructor supported. They're flexible. You can set your own study schedule, and you can enroll 365 days a year. The content on them is deep, well-rounded, in-depth. They're affordable, priced under the national average. Most importantly, they're designed for absolute beginners. No tech knowledge or experience is required, so you don't have to be a nerd to get through these programs. Now, I am in a lot of the curriculum videos, so you have to experience me being a nerd, but I don't know how to get around that. I am who I am. And who are these programs for? Well, anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. It allows for great work-life balance, and it pays really well. So we consistently land on every major best coding bootcamp list out there. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, which is pretty cool because it's based on student and graduate feedback. These are the people that have actually experienced what we do, telling people how good it is. So why work in tech? Well, a couple of reasons. It's got great work-life balance. You're not going to find yourself working 60, 80 hours a week in tech, which is awesome. I've had jobs like that. And a lot of jobs allow for remote work in full or in part, especially post-COVID. It's also a really creative industry. Even though you work with machines and they're all yes, no, true, false, and all that kind of stuff, the work itself is really creative. It's dynamic. You're solving really fun, interesting problems with really bright people. You get to work with really, really cool, bright people, unless you're working with me. You also get to take a lot of personal pride in your work. And it is a stable industry that pays really well. And if you keep applying yourself and learning more, you get regular increases in pay. The average salary in America for a software developer is $121,000 a year. That's the average salary. Meanwhile, the average across all industries is $59,000. So the average for a software developer is literally twice the average. Now, everybody's got their own career trajectory and everything, but technology pays well. That said, if you're considering getting into tech with a boot camp specifically, there are some barriers. We'll acknowledge that. There's only 3 ways to get into tech: self-study, college, boot camp. Those are the only ways. And they each have their pluses and minuses, but there's some barriers to doing a boot camp. One of the biggest ones is the cost. It costs thousands of dollars to do a boot camp. Now, what we've done to handle a lot of that is a couple of things. One, we have multiple financing options, including a rather large upfront discount. You can just pay for the whole thing upfront. And if not, we've got monthly payment options for any kind of credit. The big thing I'd say here, though, is that I consider getting through a Tech Academy bootcamp genuinely to be an investment in yourself. You are giving yourself a set of skills that is extremely valuable and will be for a very long time, because you're able to do things that, one, lots of people either don't know how to do, or two, they don't want to do. And the things you can do provide lots of value. So when it provides lots of value and other people don't want to do it or don't know how to do it, you're the person. And that's part of why you can have so much value. Another barrier to doing a boot camp is the time. No joke. I mean, there's a lot to get through. Okay. Now, some boot camps try to handle this through running what they call a cohort system, where they batch everybody together and nobody starts yet, and then they all start on the same day. And then they all go through the curriculum at the same pace. Kind of like high school. I don't know about you, but I found that not everybody learns at the same pace. Thank you very much. So, got a lot of things to say about that. Some boot camps even make you study in person to try to handle this time issue. Our programs are fully online, and you choose your study schedule, and it's self-paced, which is huge. Part-time studies allowed, which means you can study concurrently with holding down a job or even while you're in school for something else, okay? Now, here's the biggest one. You do have to have some technical interest or ability to get through a boot camp. I will say this: you're on this class, probably you have some interest that's technical in nature. I want to cover that ability part. It may not be everybody in this call, but it's real to me that many of you have experienced occasionally, like trying to study something technical, doing a tutorial or reading an article, trying to wrap your head around something relating to coding and starting to feel stupid. Like it's just too hard. There's something here I'm not getting. Most of us have felt that. And the thing I want to point out is in almost every case, it's not you, it's the curriculum. Lots of technology education materials are frankly too hard. And the reason for it is that some educators assume too much prior knowledge on the part of the student. I did this early on and we cracked it. We don't do that. With our programs at the Tech Academy, you don't have to be a nerd. There's no technology background needed to enroll, which is really awesome. So that brings me to a question, really. A couple of questions. And I know this is going to be true for everyone, but just ask yourself, are you working a dead-end job? And I don't mean that to be derogatory. Perhaps you really even frankly enjoy what you do, but by dead end, I mean if you project forward 5, 10 years as you were to move up in that, is that ceiling in that job where you actually want to be? Can you actually make the kind of money in that field that you want to? Is it something you truly want to be doing 5, 10, 15 years from now? Or maybe you're frankly unemployed. Or maybe you want to work from home, but the kind of work you do right now either physically can't be done from home, like you're laying bricks, or the company you work for, while it might be technically possible, you're in an industry that would never allow it. But if that's important to you, it is. Or maybe you want to spend more time with your loved ones and you're working 60, 70-hour weeks or something absurd. In other words, is it time for a career change for you? If it is, the Tech Academy is the solution. We are career change experts. That orange bridge you see in our logo is there for a reason. We wanted to build the route into technology for everyone. And at this point, we have over a decade of experience in breaking people into tech. Thousands of people. And most of our graduates make on average $30 an hour in their first job. That's $60K a year. So right out of the gate, the average is $60K. And of those over 1,000 graduates we have working in tech, they're everywhere, not just like big companies, not small ones, everything. Small mom and pop, small, medium-sized businesses, Nike, Facebook, Uber Games, Epic, like they're everywhere, right? So as a reminder, we have open enrollment. You can start anytime, and I encourage you to enroll now. But I really encourage you to enroll like with a quickness. And the reason for it is the end of August. And if you apply now, we'll consider that you are eligible for what we did in August. I say did because we're almost done with August. We had a phenomenal August. Phenomenal. One of our best months in a long time. And the reason for it, I think, is this. If you enroll this month, and all you'd have to do is just apply, just fill out the form in the link we're going to give you. As long as you do that, you'll qualify for this. One, massive tuition discount if you can pay up front. 50% off. That can be worth $5,000, $10,000 depending on what boot camp you're looking at, okay? And if you pay up front and you need a laptop, we will send you a refurbished laptop if you're in the US. Also, if you apply this month, no sales tax. We'll pay it for you, no matter where you live. Also, we'll send you our coding books, including our Intro to Coding book, our Computers and Tech Simplified book, which is amazing, and our Technology Basics Dictionary, so you have access to extremely well-written, clear, simple definitions for everything as you go through your program. And we'll give you a free copy of our Career Planning Guide. This is formally only for graduates, but we'll give you one so you can start planning your career really well. I could talk about this for a half an hour. There was no such thing when Jack and I, my co-founder and I, sat down to build this. How would you plan out the first 3 years of your career if you knew everything that Jack and I know now? That's what we put into that. How do you plan the first 6 months, 18 months, 36 months? What do you do in what sequence to set yourself up really well once you get that first job? It's all in the Career Planning Guide. It's really valuable. You'll also get 3 months of free access to one of my favorite things we do called the Tech Academy Accelerator. This is a program that gives you access to over 100 free videos, educational videos, 100 free courses. But most importantly, we do weekly workshops that are super nerdy, deep dive, actual career accelerator workshops. We build things, we get our hands dirty, we do a deep dive into stuff. They're real fun. They're open voice, open video. It's a community. Okay, you get 3 months of access to that. And biggest one, you get unlimited job placement assistance. That's huge. Our job placement personnel have gotten literally thousands of people employed in technology, and they know exactly what they're doing. And so when you're done with the training part of your program and you've done the live project, you've been part of a development team, and you're like, man, I really feel like I can do this, and you move over into job placement, you have access to that training material and those personnel for as long as it takes for you to get that first job, period, end of story. If you'll keep working at it, we'll keep working at it, which is phenomenal. It's phenomenal. It was a big decision to see whether we just commit our personnel to that, but we want the outcome for you. We want you working in tech. So again, all you'd have to do is submit the form today. And if you end up getting your tuition, it'll count as an August tuition. So this is the contact form. Jessica, can you drop that in to chat? And stick around for your free gift. We're almost there. If you just fill out the form, what comes after the form is a really cool series of steps all about the Tech Academy. Videos, articles that explain everything about how we do what we do so you can make a really informed decision. You can even book a call with admissions from there. Okay, there's the link in chat. And I'm going to take a sip of water because I've been talking a lot. By the way, the reason there's this login credentials things at the bottom of the slide, if you go to that link and it takes you to a login screen, it's just that you already have an account with us. And if you've forgotten how to get in, that's what those credentials are all about. All righty. So yeah, if you got the slightest bit of interest, I highly recommend filling out the form because it'll register you as an August applicant. We have people that have saved, depending on the boot camp they're getting. Like it's literally like a $13,000 value for some people, depending on which boot camp they get. Especially when you factor in professional career advice on getting hired is really, really, really worthwhile. So that unlimited access to our job placement personnel and training is a big deal. All right. Couple quick notes. We have a referral program. It's pretty awesome. Graduates love us. And so for years, referrals have been one of our biggest sources for enrollments. And so years ago, we put in place a commission payment structure. And that's not just for graduates. It's for you too. If you've got someone you really feel should be talking to us, then we'll give you an opportunity here in a moment to send that information in. We'll keep track of it. And if they end up signing up, we're going to send you 5% of their tuition just for thank you for referring them. We mentioned books. We have 7 books, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, which is amazing, by the way. If you've got young people that are interested in tech, get that book. It's on Amazon. We've got the Technology Basics Dictionary that I talked about, the Project Management Handbook, which tells you all about how software is made, and You Are Not Stupid. It's the book I wish I had like when I was 13. It removes all mystery from computers and technology. This is the free gift. Yep, Jessica, I remember William's question, okay? This is the free gift. It is our Intro to Python book. And it says intro. Man, you can learn so much from this thing. I think it's 60 pages or something like full. You know those 5 fundamental elements of any computer program that we went into? Fully expands on that in great detail, teaches you all the key instructions in Python, has you build lots and lots of things all on a simple gradient. It's really, really awesome. So how do you get one? Well, Cheska just dropped an email address into chat, the books at learncodinganywhere.com. Send us an email saying I was at Erik's Python class. I'd like my free copy of the Python book. Here's my address. Don't forget your address, and they'll send you a copy of the book. Also, if you have referrals, throw them in the email. If you've got further questions for me, throw them in the email and they'll get sent to me. Atik says, not from the US, how can I get that book? You can find it on Amazon for really inexpensive. In fact, the PDF version is real cheap. So Atik, just go to Amazon and look up Learn Coding Basics in Hours with Python, or you can look up Erik Gross or Jack Stanley, and you'll find our books. All right, now, while I'm waiting on that, I'm going to answer William's question. I'm going to go back to the code here for a second. He asked, what's up with the while true? So, I think William, you still there? Let me pop up in chat. Let me know if you're still here, William. Awesome. Okay. So it's actually easier to explain what the heck this is all about by changing it a little bit. What if we change it to while turns less than 4? It'll probably make a lot more sense to you now in terms of almost reading it like English. The while is just another way to build a loop. It's a way to have a set of instructions happen over and over again until a predefined situation occurs, until a predefined condition occurs. In this case, the condition is as long as turns is less than 4, then keep on doing everything that is in the code block. Now, of course, William, that's not how this code is written, but it helps explain the while word a lot more easily. So, first of all, William, does that make sense? The concept I just discussed. Good. Now, let's get a little more abstract about it. What we're really saying is, while this is true, while the expression is true, then keep on doing everything in the code block. Isn't that what we're really saying? So when you do this, that means we're just gonna keep on doing everything in here because it's always true. You use this when there's a set of instructions that where you just want to keep on going until something happens inside the set of instructions. Specifically, keep on going until the player decides they want to stop. If the player enters the word exit, only then do you print goodbye and check this out. That gets you out of the loop. This was going to continue until the end of time because we said, while this is true, well, of course it's true. True is a keyword built into Python that just means always true, I'm always true, I'm always true. So this thing's never going to stop unless inside it, we give it a way out. And this is the way out. That's how we stop it from running. Does that make sense, William? Awesome. I love your question. There's many different ways to do loops inside of computer programming languages. And this while loop is a really effective one. But unless you built one that you want to run always, this while true looks really weird. So, good question. All right, let me get back here. I want to talk about our link tree, okay? Linktree is awesome. If you haven't used Linktree or seen one, Jessica, can you drop the link to Linktree in there? There it is. This is just all of our links, all of our socials, all of our free educational YouTube videos, our books, our upcoming classes, our meetups. So you can find out where the next classes are by going to this link tree, and you find all of our social accounts. So follow us on social media. We'd love that. And the last thing I want to say, like seriously, if there's even the slightest interest in your part, go to this link and fill out the form. We'll know that you filled it out in August because it's registered. Start watching the steps afterwards. Watch the videos. Yes, you're going to have to see me on video. I'm sorry. But seriously, we just explain, like, how does our program work? What's special about it? How's it different? What makes it work? What do people have to say, you know? And so you can find out everything about it. And then if you do decide, hey, yeah, this makes sense for me, then you can take advantage of all those August specials. That's what we have. Really appreciate you taking the time. Hey, 8:30 on the dot. I'm in Central Time Zone. And we'll see you at the next event. Otherwise, have a great evening. Thanks all. Bye-bye.